So, students, we have to discuss about Fajan's rule, where we shall be dealing about the polarization and the polarizing power. So, already we have discussed three types of bonding, that is ionic, covalent, and coordinate bonding. After that, we shall be dealing that what does Fajan's rule explain. So, for this, let us consider two charged species, A positive and B negative. Now we are observing that when these two species will approach each other, firstly, there will be repulsion between the electrons. There will be also repulsion between the dense positively charged nucleus of the two ions, and there will be attraction between the positively charged nucleus and the electron. So we can summarize the point as when the ions, that is A positive and B negative, will approach each other for the bonding, we find that there will be attraction between the valence shell electron of one ion and the positively charged nucleus of the other ion, and vice versa. Point 2, we find that there will be repulsion between the electrons of the two ions as well as the nucleus of the two approaching ions. Now, these different type of forces will lead to distortion in the shape of both the ions, means A positive, due to these repulsions or attraction or such forces, it will try to distort or change the shape of B negative, and similarly B negative will also try to distort or change the shape of A positive. So when the species will approach each other, we had dealt that there will be action of these forces. There will be attractive force between the positively charged nucleus and the electron. There will be repulsive force between the electrons of the two approaching ions and the nucleus of approaching ion. So due to the action of these forces, what we find that the shape of these ions will be distorted, will be changed. So here we are finding that A positive will try to distort B negative, that is anion, and B negative will try to distort the shape of A positive. These distortions in the shape or the size is just due to the forces which we have discussed earlier. That is, when cation and anion, that is A positive and B negative, will approach each other, there will be inter-electronic repulsion, internuclear repulsion, and the attraction between the positively charged nucleus and the electron, and this will lead to distortion, which we call as Fajan's rule. Now, generally what we find that in case of ionic bonding, where we have the approach of A positive and B negative, the size of cation is smaller as compared to that of anion. Now, smaller size of ion means that nucleus of the cation will be closer to the valence shell electron of the anion, and hence it will lead to greater distortion as compared to that of anion. Let us see here. Suppose for A positive, we have taken it, this is the nucleus, electron. For B negative, let's say its size is larger as compared to the cation. Now, what we are observing here, that due to the smaller size of A positive, its nucleus will be very close from the outer part of the ion, and hence the approach between this positively charged nucleus of the cation and the electron of the anion will be closer. And due to closer approach, what we find that these two, that is the nucleus and the valence shell electron of B negative, will be interacted maximum. Maximum interaction means this positively charged nucleus will try to attract the electron towards itself, and attraction means the path of the electron will be changed, and this change in the path of the electron will lead to the change in the shape, which we call as distortion. While if we find or observe B negative, its nucleus is very far away from the valence shell electron of the cation, means the distance between the valence shell electron of A positive and the nucleus of B negative is far. Hence, this too will lead to lesser interaction. Lesser interaction means the positively charged nucleus of B negative will try to pull this electron of A positive towards it with a weak force, and weak force means the distortion will be almost insignificant or negligible. That is why we nullify, and what we say that during the bonding between two ions, if the size of the cation is smaller as compared to the anion, then the distortion in the shape of B negative will be made greatly by A positive, while due to larger size, B negative will lead to smaller distortion to A positive. Now remember this trend, the concept of distortion which we are discussing here, that is only the Fajan's rule. So according to Fajan's rule, whenever two ions will approach each other for bonding, then during that time we observe that cation tries to distort anion, and simultaneously anion also tries to distort cation, but due to the smaller size of cation, the distortion made by cation to anion is of more significant, and the distortion made by anion to cation will be of less significance due to its larger size, and that will be called as Fajan's rule. So we have discussed about the Fajan's rule, that during the approach of ions towards each other, there is distortion in the shape of both the ions, and this distortion will bring a decrease in the ionic character and increase in the covalent character. Why the ionic character will be decreased or the covalent character will be increased? Let us discuss it. Now, as we have already discussed in the ionic bonding concept, that whenever two species undergo ionic bonding, we find that the electron cloud density is not equally distributed at the center of both the nucleus of both the ions. What does this mean? That if these two species have formed an ionic bond with each other, then a bond means electron cloud. So basically we find that there will be presence of electron cloud between these two ions, but they are not equally distributed or equicenter from the nucleus of both the ions. Whereas in covalent bonding, what we find that the species undergoing covalent bonding will have equidistant electron cloud from both the nucleus of the bonding atom. Means, let us say we have taken a bond between A and B, which is covalent in nature. Then if this is the electron cloud, then this electron cloud will be equally separated or equidistant from the nucleus of both A and B. Whereas the electron cloud between A positive and B negative is not equally or equidistant from the nucleus of A positive and B negative. Now, here we are finding that during the approach between A positive and B negative, if A positive is polarizing or if A positive is distorting the shape of B negative, that will lead to the approach of the valential electron of B negative to move towards A positive, due to which the electron cloud will go on becoming equidistant from the nucleus of both A positive and B negative. Now, here we have observed that in case of ionic bonding, the electron cloud is not equidistant from the nucleus of the bonding ions. Whereas in case of covalent bonding, the electron cloud of the bond is equidistant from the nucleus of the bonding atom. So student, in ionic bonding, the electron cloud of bond is not equidistant from the nucleus of the bonding ions. Whereas in case of covalent bonding, the electron cloud is equidistant from bonding atoms. So if we observe, we find that due to the polarization made by cation to anion, the valential electron of B negative starts approaching towards A positive, and that will lead to equal or equidistant distribution of electron cloud between the nucleus of both the ion. Means, although these ions are approaching each other, where we should have ionic bonding, but due to this distortion, we are finding that the covalent character is increasing and hence ionic character is decreasing. So this is what we have to discuss in Fajan's rule. So according to Fajan's rule, during the approach of ions to form ionic bonding, due to the distortion, we find that the covalent character increases and the ionic character decreases. Now, next thing, remember, so here we have seen that cation on approaching anion starts distorting the size or the shape of anion, and this distortion made by cation to anion will be called as polarizing power. So we can define polarizing power as when ions approach each other, smaller cation tries to distort or change the shape of larger anion, and the power of the cation or the tendency or the ability of cation to distort or change the shape of anion, that phenomena or that power will be called as polarizing power. Let us discuss that on what factor polarizing power will depend. So student, with the decreasing size of cation, we find that the polarizing power or the power of cation to distort anion will increase, because smaller is the size, more will be the approach or the distance. So as the size of cation will be decreasing, its nucleus will become more closer and closer to the valential electron of the anion. So more is the closeness, or if the gap between the positively charged nucleus of the cation and the valential electron of the anion decreases, then in that case what we find, the cation will lead to more distortion and hence will have more polarizing power. So point 1 is, if the size of the cation decreases, then the nucleus will become more closer with the valential electron of the anion and hence will lead to more distortion, and that is why it will have more polarizing power. Second point, we have written that larger charge on cation favors polarizing power of cation. Now student, cation means a species which has undergone the loss of electron. Large charge on cation means more loss of electron. More loss of electron means there will be less number of shell, and less number of shell signifies the small size of cation. And again, if the size is smaller, then in that case again there will be more polarization or more distortion will be made by cation to anion. So these are the two factors on which polarizing power depends. Point one is small size of cation, and second point is large charge on cation. So already we have discussed that cation due to small size distorts the anion, and this distortion process is called polarization. So we can define polarization as, so due to small size of cation, it will lead to distortion, means it will distort anion. That effect will be called as polarization. So during the approach between the ions, we found that cations due to small size distorts the anion. Now we have discussed polarizing power, that cation tries to distort anion, which is called polarization, and the power of cation to distort anion is called polarizing power. Similarly, anion will have tendency to undergo polarization or will have tendency to undergo distortion, and this distortion will be called as polarizability. So we can call polarizability as, so like polarizing power, if we discuss that how polarizability should increase, then with the increasing size of anion, what we find that if the size of anion increases, then the valence shell electron of the anion will move more closer to the nucleus of the cation, and hence it will undergo more distortion or it will have more change in its shape. So if the size of anion increases, then its distortion will be increased, and hence polarizability will also be increased. Similarly, if the charge on anion is increased, then again that will lead to increase in the number of shell, or that will lead to the increase in the size, and again that will have more distortion and more polarizability. Now we shall discuss that what is the effect of polarizing power and polarizability on the covalent and the ionic character. So we have already discussed that if the distortion made by cation to anion increases, then in that case the covalent character increases and ionic character decreases. So if polarizability is increased, or we can say if the polarizing power increases, then in that case there will be increase in the covalent character and there will be decrease in the ionic character. So with the increasing polarizing power, polarization increases and hence covalent character increases and ionic character decreases. If the polarizing power of the cation will increase, then in that case that will lead to increase in the polarization. Simultaneously the covalent character will be increased and the ionic character will be decreased. Also remember that if the polarizing power increases, then the polarizability also increases. So either by increasing the polarizing power or by increasing the polarizability, there will be increase in the polarization or distortion, and hence the covalent character will be increased and the ionic character will be decreased. Point to remember that size of cation decreased or size of anion is increased, these two will increase covalent character. Means if the cationic size is decreased or anionic size is increased, the covalent character will be increased. Why? We have discussed that with the decreasing size of cation, the polarizing power increases, and if the polarizing power increases, then there will be increase in the polarization and hence increase in the covalent character. Similarly, if the size of anion is increased, then polarizability will be increased, and increase in the polarizability means increase in the polarization, and increase in the polarization means increase of the covalent character and decrease of the ionic character. Similarly, if we move to the third point, we find that so by increasing charge on cation or by increasing charge on anion, what we find that again there will be increase in the covalent character. So students, polarizability refers to the tendency of anion to get distorted, and polarizing power refers to the ability or the power of a cation to distort or polarize anion. Now, with the increasing polarization, we found that the distribution of the electron cloud will be equidistant from both the nucleus of the cation and the anion. That will lead to the increase in the covalent character. Now, we can define that how covalent character can be increased or can be changed by the polarizability or the polarizing power. For that, if the cationic size is decreased or the anionic size is increased, then there will be increase in the covalent character, or if the cationic charge is increased or the anionic charge is increased, then again that will lead to the increase in the covalent character.